Okay, as I was saying before I got cut off in my last video, is this limit as we go to infinity is 12, and the limit as we go to negative infinity is 12, and that is something called end behavior. Whenever you are asked about what's happening on the far right side or the far left side of the graph, what they're really asking you is end behavior. And that's something that you should have talked about in college algebra. So we're not interested in what's happening in the middle. We're interested in happening what's out here. And the horizontal asymptote is completely responsible for creating that end behavior. So this one, we'll notice that this graph is headed to 12. And so that horizontal asymptote is at 12, even though maybe if you didn't even see the graph, you could tell that that's what the horizontal asymptote is. So if you look at this, and I know it's kind of hard to see, here's 12 right here. If you could imagine, you should always draw these as dashed lines, right? If we go out here on both sides, you can see that on the right side, this comes from underneath and it's coming up to 12 from underneath. And that's exactly what these numbers told you. See how they're smaller than 12? You're coming up to 12 from underneath. Over here on the left side, you're above 12, headed down to 12. See, your numbers were bigger than 12 and you were headed down. So you can get a feel for if the graph is above or below the horizontal asymptote if you look at the table. For this one, I actually think the graph is the easier way to go. And whenever you see this flattening out on both sides, that's end behavior happening, and that's horizontal asymptotes. Now, you might have also learned a little trick in algebra about if you compare the highest exponents, so the pieces with the highest exponents in this case is 12x squared on the top and x squared on the bottom. If you compare those, there's some rules about if the exponent on the top is bigger or the bottom is bigger, or if they're the same. In this case, they're the same. Because they're the same, it tells you that 12 is the horizontal asymptote. If you don't remember those rules from algebra, it's fine. You don't have to know them. But it's kind of nice to know the answer before you head into the problem. All right, and on this one, you'll notice I don't have a section about algebra. We can't simplify that. Well, I don't know, maybe that could be factored, but I can tell you the bottom can't be factored, so it doesn't do us any good to do algebra on this particular one. All right, last thing we're going to do here is we're going to talk about a big graph, and then we're going to look at all the different limits for this particular graph. All right, so you'll notice it's a crazy graph. It's got asymptotes and holes and all kinds of crazy things. There's a hole here. That's a hole. There's a hole over here. You've got some vertical asymptotes, all kinds of crazy behavior. And I kind of have the questions broken up into lines. So each line is asking about a specific part on the graph. This says, what is the limit as x approaches -6 from the left? Part B is what happens as you approach -6 from the right. And part C is what is it overall? And remember, you're only going to get an overall limit if the left and right sides can agree. So let's just hone in on -6. And so -6 is over here. I'm going to put a sticky note to cover the rest of the graph here. So we just want to focus on what's happening at -6. So ignore the rest of the graph, okay? As you approach -6 from the left, you want to think of the curves, those blue curves, as the roads that you're driving on. So if these are the only roads that you have, as you approach -6 from the left, as you try to get closer to it, you have to be on this road. It's going to force you north. You're headed to infinity. So on the left side of -6, you're forced north to infinity. What's happening on the right side of -6? Well, remember, don't drive away from -6. You're trying to get to -6. So the road is going to take you down. You're trying to decrease the space here. So that road's going to take you down to -infinity. And do those agree? No. So we say D and E. And you can tell it's D and E when you look at it because the sides of the graph, like, they go past each other. They go like that, or they'll go this direction. If they're going straight past each other, like 180 degrees apart, that's going to be D and E, right? Now let's see what's happening at -4. So again, I'm going to kind of try to just hone in on what's happening there at -4 and try to ignore the rest, because sometimes it's distracting. All right, if we head to -4 from the left side, so I'm wanting to come in this way, I have to drive on this road. And where's it taking me? It's taking me right to 2. And I know that's 2 because the point was labeled. Or you can look at your y-axis there, but you can see. This road took me to 2. Don't argue. Don't overthink it. It's taking you to 2. If you want to head to -4 from the right side, you'd be on this road. And as I drive in towards -4, this one's taken me to 3. Are they the same? Nope. And you can see there's a big old jump in the graph. There's a gap. The left and the right sides are not taking you to the same place. You're like a block apart, okay? All right, now let's look at the next one. I want to see what's happening at 0. All right, so again. Oh, and there is a point right there. I don't know if you could see it when you graphed it, but there is like a floating dot right there. So we want to look at the limit as we approach 0 from the left, the right, overall. Okay, if I want to approach 0 from the left side, if I want to get closer and closer to 0, I have to travel this road. And where is that road taking me? It's taking me right to that hole. That hole is at about, we're going to call it 3.5. The left side's taking me to the hole. Where's the right side taking me? To the hole. Do they agree? Yes, they do. The overall limit is 3.5. But I know what you're thinking. You're like, well, but what about the dot? What about the floating dot? Yeah, that's not important when it comes to limits. Limits is the behavior of the curves, right? These lines and curves. It's not what's happening at a specific point. It's what's happening around the point. So the behavior is, it's taking you to 3.5. You're going to 3.5 whether you like it or not. That's what the limit is, okay? And then let's look at what's happening at 3. So here's 3. 3 is this asymptote right there. That's 3. So look at the behavior on the left side and on the right side. If you were trying to get to 3, so you're heading in this direction from both sides, where would those roads take you? They're both going straight down to -infinity. And those agree. So we're going to say the overall behavior is -infinity. Okay? Those agree. I know it doesn't look like they're going to exactly the same point. Again, the idea is the behavior is that they're headed south. Both sides are headed south, so you put -infinity. Now, I do want to go back and talk about one more thing on here, because I think we need to talk about it, and that is function values. So I'm going to work in function values over here. And I want to talk about f of -6, f of -4, f of 0, and f of 3. Now, to do function values, that's an algebra topic. You don't need any calculus. The concept of a limit is calculus. This is just algebra. When I ask for a function value, I am talking about an actual dot or an actual line. You cannot have a hole, you cannot have a vertical asymptote. It has to be an actual, like you could write the XY coordinates for the point if you had to. So at -6, if you look up and down, do you have a dot or a point or anything? No, because this is a vertical asymptote. So function value does not exist. You don't have one. What about at -4? If you're at -4, if you look up, you go, okay, well, it's going to be one of two things. It's either going to be 2 or it's going to be 3. Now you have to understand the whole is like imaginary. It doesn't really exist, right? So if you had to pick, the actual function value is 2. Because that's a point. Now I understand the whole has coordinates too, but it's a gaping hole. It's imaginary. What about 0? If you look above 0, which of these, is it 2 or is it 3.5? Which one's the actual function value? 2. It's where the dot is. And then what's happening at 3? Do you have a function value at 3? No. You have a vertical asymptote. And so that's another one. Do not exist, does not exist, however you want to say it. So what's in blue here, this is the calculus. This right here is just the algebra. And the point I'm trying to make is, whether it has a function value or it doesn't have anything to do with the limits. Because if you cover this up, we can still find the limits. And the limits are not always the same as the function value, okay? So they're really kind of two separate concepts. You either have a function value or you don't, or you have a limit or you don't. They don't always mean the same thing. Just like here, we had a limit that was 3.5, but the function value was 2. Like they didn't play into each other at all, okay? So this is a really, really important concept, though. You've got to be able to look at a big crazy graph and then ask or answer a bunch of questions like this. I think I generally tend to put questions like that on the lab that you guys are going to be doing.